The second last type of word problem we're going to do is called a mixture problem. So you're going to identify these problems because it's going to be a mix of two things, and it's not going to be like the last two. So the last two, it was like each sentence got transferred into an equation and then you solved your system. This one, it's going to be like a mixture of two things, and it's going to feel a little bit more off-putting. But what I do is I use what I call an art chart to solve these problems, and it helps me figure out what my two equations are. So let's start off by reading the equation. So it says, how many liters of each 40% acid solution and 70% acid solution should be mixed to obtain 120 liters of a 50% acid solution? So right away you can tell why these are called mixture problems is because you're mixing two things together and like physically mixing, like they will go together. In fact, if I showed you a picture of this, so here's my 40% acid solution. So I'm going to pour it into this nice little flask here. And so this is I have X amount. I don't know how many liters of the solution I have, but I know that, let's do acid in green. We know that 40% of this solution is acid. So I have X liters of the solution, and then in the solution, 40% of it is an acid. And then my next solution, same size. Okay, I have, let's say, Y amount of solution. So I don't know how much, but I know that 70% of this solution is acid. So what I'm going to do is I'm going to be mixing these two together. So I'm going to be forming a new flask. Let's say it's red. Okay, let's draw it the same size. But I'm going to have my X amount of solution and my Y amount of solution. So it's going to be really full. So this is going to be my X and my Y solution together. But I also know that together there's going to be 120 liters in here. So I know that when I mixed X amount of solution A and Y amount of solution B, that they mixed together and made a whole solution that was 120 liters. Then we also know that 50% of this solution is acid. Okay, so this one is 50% acid, this one was 70% acid, and this one is 40% acid. And what we want to do is try to make this information into two equations, so into a system of equations that we can then solve. So what I like to do first is look at what I'm solving for. So it says I want to know how many liters of the 40% acid solution and the 70% acid solution I'm going to have. So I'm going to let amount of 40% solution be X, and I'm going to let the amount of 70% solution be Y. And then these are going to become my headers. So the 40% solution is going to get mixed with my 70% solution, and I'm making a 50% solution. Okay, so again, this is sort of my picture. I've got my 40% solution mixing with my 70% solution to make my 50% solution. And how much 40% solution I have is X. How much 70% solution I have is Y. When they're mixed together, that 50% solution is 120 liters altogether. This is going to be equation 1. Now to figure out equation 2, in this case, I'm going to make it based on how much acid is in the solution. So I'm going to have a rate, which in this case is going to be the percent acid. So whenever you use percentages, you can't put 40 in here because 40% actually means nothing. It's 40% means 40 out of 100. So in for here, I'm going to put 0.4. So always put your percent acid as a decimal. So anytime it's talking about percentage, and now percentages could be acid solutions, they could be amount of juice in a container, and as you'll see in a couple examples, it could also be like an interest rate as well. So percentages could be different things. And so for this one, you've got a 40% acid solution, so the rate of that is 0.4. The rate of the 70% is 0.7, and then the rate of the final solution is 0.5. Then what's going to go down here, and again, you know, these words, you pick words and then they don't fit every situation, but this is going to be the amount of acid. So this is the total amount of liquid, right? So you have X amount of liquid plus Y amount of liquid gives you 120 liters of liquid. This is going to be how much acid is in the liquid. So 40% of X is acid. 70% of Y is acid. And then here, 50% of the 120 liters is acid. So that now I have equation 2. So to write my system, I have x plus y equals 120. And then I have 0.4x plus 0.7y equals 50% of 120, which is 60. So this is my system. So it might seem confusing the first time you do it, but trust me, with practice, it'll feel better and better because they're all like this. It's always that first line. How much total liquid do you have? How many total, bags do you have? How much total juice do you have, right? Or liquid that's made up of juice. But it's that first line. And then the third line, or your second equation, is always going to be how much of that is acid, or how much of it is juice, or how much of it is, cement, or something along those lines. And you'll always come up with two equations that look like somewhat like this. Now to solve this, you have lots of options. You could solve this by elimination. So I would maybe multiply this equation by 10. So I get 4x, 7y, and 600. And then I could multiply this one by -4 or -7 to get rid of the x or the y variable. Or I could solve by substitution. I could take this equation and solve for y, or I could take this equation, I could solve for x. What I would love for you to do is pause the video, you pick which way you want to do it, and then check your solutions with what I get. I'm trying to think in my head how most people will do this. I'm going to solve by substitution, because it's how I see most people do it. But I do love that elimination. I do love multiplying this equation by 10 and then the top equation by -4, but totally up to you. I'm going to take this top equation and solve for y. So y equals 120 minus x. So I'm going to subtract x from each side. Then I'm going to substitute in this 120x. I'm going to substitute it into this equation for y. So what's that going to look like? I'm going to have 0.4x plus 0.7 times 120 minus x is equal to 60. Then I'm going to distribute, because I'm now solving a linear equation in one variable. So I'm going to simplify the equation first. I get 0.4x plus, I should have chosen elimination, I wouldn't have had to use my calculator as much, 0.7 times 120, so 84, and then minus 0.7x. Then I'm going to collect like terms, so 0.4x minus 0.7x is negative 0.3x plus 84 equals 60. I'm going to isolate the x term, so I'm going to subtract 84 from each side, and I end up with negative 0.3x equals negative 24. And then to isolate x, I'm going to divide each side by negative 0.3. I end up with x equals 24 divided by 0.3, 80. Now the question asked me how much of each did I have, so now I have to take that 80 and plug it back in to solve for y. And again, you can plug it into any equation you want. I'm going to plug it in here, actually. So I'm going to then say that y equals 120 minus 80, so that y equals 40. And then I'm going to solve or answer my question. Therefore, 80 liters of 40% acid will be mixed with 40 liters of 70% acid. And if you look in the back of the book, I think they literally go like 40% ... 80 liters. Like, I'm totally fine with that. And then 70% ... 40 liters, right? You can do that too. So either of those would be fine, but show me that you know what you solve for. Ideally, it's an amount, but the textbook doesn't do it, so I can't expect you to do it. Yeah, that's the first one. So let's do another mixture problem. So it's going to feel similar, but very different in the same token. So the next question, we have a gummy mix is made by adding sour worms that cost $1.49 per kilogram to gummy bears that cost $2.15 per kilogram. How much of each should be added to obtain 33 kilograms of a mix that will sell for $1.75 per kilogram? So again, I noticed that this is a mixture problem because I'm going to put two things together and like literally put them together in a bag. It's not like when you had 3 football tickets and 2 baseball tickets. I mean, sure, you're mixing 2 things, but not in a bag, right? You're just looking at two different scenarios. This one is actually a mixture. So what are the two things we're mixing? So let's let amount of sour worms be. I hate S's. Let's go W. And then gummy bears. Let's do that one as B. So we've got worms and bears. So those are the two things that we're going to mix together. So the two things that we're going to mix together are the worms and the bears. And then what are you going to get here? It's going to be a mixture. So this is going to be your mixture. So this first line is how much of the worms and how much of the bears are you going to mix together? Well, we don't know, right? So we're taking some worms, like a bag of worms and a bag of bears, and we're making a big mix. But we know that the mix is going to contain 33 kilograms of bears and worms. So let's say the amount of worms is W and the amount of bears is B, and then the total mix is going to be 33 kilograms. Then we got to figure out another equation because now we have one equation with two variables and we can't solve it. So now let's take into consideration the money part. Well, we know that the sour worms are $1.49 per kilogram. That's your rate. It is $1.49 per kilogram. The bears are $2.15 per kilogram. And then my mixture is going to cost $1.75 per kilogram. So what are we going to do with this? Well, there's no variables. So let's figure out the total price. So the total price of my gummy worms is going to be $1.49 times however many kilograms of worms I have. So my total price is going to be $1.49 W. My total price of the bears is going to be $2.15 per kilogram times the kilogram of bears. And then the price of my mix is $1.75 times, I know that I have 33 kilograms of mix. So this becomes equation 1, this becomes equation 2. So yes, it's a totally different scenario than the one above, but we set it up the same. Both of them, you get x plus y equals a total amount, right? Whether we use x's and y's or w's and b's. And then my last line is always taking into consideration this percentage or this rate, right? This money per kilogram. And the questions will always look similar to this. So now let's set up our system of equations. So we've got w plus b is equal to 33. And we've got $1.49 W plus $2.15 B is equal to, now let's go 1.75 times 33, 57.75. That's a lot of money on candy. All right, and now we can solve this. You can either solve it by substitution or elimination. If I was going to do elimination, I mean, you could simply multiply this top equation by negative 1.49 or negative 2.15. Or you could multiply the bottom equation by 100 and then do them in the hundreds, or a substitution. And again, I find a lot of people do substitution. So I'm going to say B equals 33 minus W. So now I'm going to take this 33 minus W and I'm going to plug it in for B. So I'm solving by substitution, but elimination is awesome as well. So now I've got 1.49 W plus 2.15 times 33 minus W is equal to 57.75. Now I've got a linear equation in one variable, so the first thing I'm going to do is simplify by distributing. So I'm going to have 1.49 W, and then I'm going to distribute 215 through. So 2.15 times 33 is 70.95 minus 2.15 W equals 57.75. Then we're going to collect like terms. So 1.49 minus 2.15 equals negative 0.66 W plus that 70.95 is equal to 57.75. Now I want to isolate the W term. So I'm going to subtract 70.95 from each side. Then I'm going to end up with negative 0.66 W equals 57.75 minus 70.95, which gives me negative 13.2. And then I want to get the W term by itself, or the variable by itself, so I'm going to divide both sides by negative 0.66, negative 0.66. And then I end up with W equals 13.2 divided by 0.66 is 20. So what does that mean? Well, the amount of gummy or sour worms is 20 kilograms. So now I have to figure out how many kilograms of the gummy bears. So I'm going to take that answer that I just got, this 20, and I'm going to plug it in for W. So I get the amount of gummy bears is 33 minus 20, which equals 13. So therefore, the amount of sour worms, we'll do it like the textbook does it, dot, dot, 20 kilograms, and gummy bears, dot, dot, 13 kilograms. And then you check, right? You check back into the question. So together we had 33 kilograms, sweet. And then let's check our price. So 20 times 1.49 plus 2.15 times 13. Does that equal 57.50? Yes, and so I'm good. Or 57.75, sorry. And I'm good. So that is your mixture problems. Now this is the first two types. Well, the first two of the first type. So these are ones where they give you a rate of each individual thing mixing together and a rate of your total. The next video, we're going to change that line up. So go and practice these first.